last presentation of the day, flight material sciences.
How are we doing this evening? Able to hear me clearly enough?
Perfect.
Loud and clear and doing well.
Okay, terrific. Thanks everyone. Thanks for your patience. It's not easy to be the last one of the day, and I appreciate you keeping up the energy to stick around for this one. I'm Dan Cohen, the founder of Flight Material Sciences, and I've been an entrepreneur in the science and technology realm since the mid-1990s. Go ahead, please. So what we're working on, to give you the short version of this, is a radical new method of treating industrial materials, everything that we depend on, that prevents failure caused by ice or rust or fouling or contamination using clean lasers instead of toxic coatings. And by protecting surfaces with this new method, we hope to replace toxic coatings that address one problem but usually cause three others. We're going to use this technique to protect human life in some industries or reduce environmental damage, but really to improve the longevity of everything, and we'll get into the details. So what we're able to do is use a laser to almost any material and create a surface that protects against rust or other surface problems. And what we avoid is using any kind of coatings with their complexity and their toxicity and their weight. And we don't damage or otherwise change the nature of the trusted material. So let's get into it. Please go ahead. So this technology is about 30 years old, but we're going to try and bring this out of the lab and into commercial utility at industrial scale. On your left, you see an image of stainless steel, one of our most frequently requested materials. And it's rough and it's random when you look at it. Even if on the surface without a microscope, it looks polished. And any coating you put on there is eventually going to come off. It's eventually going to peel or break down from solar energy or because of thermal effects or chemical attacks, and it's going to scatter its material all over the place and leave the material unprotected, which of course leads to a lot of loss and damage and risk. So we're using this patented new treatment using fast energy pulses to sculpt a functional surface. And the surface on your right looks like the lotus leaf, which is commonly known, and it's super hydrophobic. Can we go to the next slide, please? It should go on its own. I hope there's a video there if you want to click on it. Just a simple video. Not working. Okay, well, this was supposed to show you the super hydrophobic effect, but if the video is not working, we won't waste time. What we're trying to show with that video is that the water bounces away from the material, and the effect is, oh, there we go. That's better. This is the video I love to stare at. So the water bounces away and cleans away material, and the effect is permanent and durable. Let's move to the next one. So we can repel or attract water-based liquids or oil-based liquids or epoxies or resins, and we can either replace or reduce or enhance the coatings on products with this. The surfaces can also be used to improve heat dissipation and even affect the friction between moving parts. And we've tested it on just about every solid material there is, so it opens up the door to a lot of applications, and we're always exploring new textures that give us new effects. Next one, please. So this has given us a lot of opportunities. It doesn't take a lot of imagination once you see that water is repelled from the surface. And each one, we could spend half an hour talking about the de-icing or ice prevention on airplanes and interesting effects in hypersonics, getting rid of ice on power lines, preventing contamination and rust on pipelines for water or oil, and even for things that are much smaller like surgical devices to give them a lifetime without coatings that wind up breaking down into the body. Next one, please. So we're often put in the coats and paints category, even though we're not a coating, but we're protective. In the protective side, this is about $100 billion a year industry that's linked to GDP and manufacturing. There's a new segment of functional coatings, which gives their material super hydrophobic properties with a coating. This is about $2 billion a year in sale and growing very rapidly. And we put ourselves a bit outside there because, again, there are some things that we can do that they can't touch. So let's go to the next one. Now, our team has got about 100 years of experience in early stage science and tech. Dr. Ogan Gurel is an MD, as well as a doctor in physics. And we've all got experience in things like technology transfer. So it's important to know that, because we are taking material that's currently in labs all over the world and bringing it out into commercial utility. So we're making arrangements with about half a dozen institutions around the world who are developing related technology to get this going. Next one, please. At this point, we thought last year that COVID-19 would slow our growth, and we were projecting 3 projects for last year, but there are currently 14 in place, and signing a new one about every 3 weeks, and a pipeline of more than 50 customer inquiries, both commercial and military, because this is a very dual-use technology. The Army, Navy, and Air Force have the same rust problems, or worse, than is happening in the commercial side. And at this point, our demand far outstrips our capacity, and we are in the middle of raising our Series A to build our own lab and respond to these client demands at commercial speeds. So the intent is to license these great technologies from the universities, make them into commercial products, and build devices that go both into manufacturing and into field use, where the long-term licensing and royalty revenue lasts between 5 and 25 years, depending on the industry. Next slide, please. So with your support, we want to try this technique on products on real world conditions in every industry and see this exciting new class of technology emerge. So please work with us to expand this mission of making everyday materials extraordinary. Thanks. I'll be happy to take your questions now.
Are you gonna provide materials like the swatch that you're showing to be applied to other surfaces? Or are you intending to like pattern the parent material? Like, you know, I'm imagining the inside of a pipe for a pipeline. That seems like it's gonna take some development to be able to do the inside of a pipe, but a lot of application.
Well, we do have a project that's designed for next quarter for the inside of the pipeline. So if the application on the outside of the pipeline is more about preventing rust and other kinds of corrosion, the inside of the pipeline will be treated to be oleophobic, which will improve oil and gas product flow. So there's less dilution chemicals needed and less energy for pumping. So yes, we're working on the inside and the outside of pipes. And in water, that's also about scale.
And how does this compare for cost, doing these big areas versus coatings?
Well, right now we're going at about 1.5 square meters per minute in terms of process speed under ideal conditions. So we've got to build the devices that go under less than ideal conditions. And the costs are expensive compared to coatings up front. But once the laser is in place and the equipment is in place, it really is the cost of electricity instead of the consumable. So if it works very well to either replace the coating or enhance the coating, the business case has to be clear, which is why we're chasing after such big elephants like rust.
I heard that at 1.5 square meters per minute.
That's right.
That's impressive. Good work.
Thank you very much.
So is this something where a manufacturer would purchase one of your machines? Is that kind of the business model here? And then it would be the pipeline manufacturer who would operate the machine? Or is this something you guys want all the pipes to come through your manufacturing facility? How's the business model work?
Well, it's mostly a licensing play. So and we've done this on this team before. So we know that we have to go to places like Chevron and SABIC and all these places and convince them that this works. And when we do convince them that it works, and they're the ones who sponsor our projects, they turn around and say, okay, FLITE, this is where we get our pipes. Please go ahead and integrate into their supply chain so we get our new deliveries with this stuff intact. But we're pursuing both the manufacturing and the field pieces because there's several million kilometers of pipe and wire and air structures already out there that we need to treat. We can't just be for new devices. Now, you haven't asked the question, but we do have several applications in the space domain, and we've applied to Air Force and Space Force for SBIRs to prove out our value, making black bodies without weight to prevent glare and to improve solar glass as just 2 applications.
Regarding, that was my question about space applications, is how about electrical properties? Does your coating change conductivity or?
Well, actually, the coatings, the treatments, not coatings, do not change the electrical properties of the material unless you ask us to. And this is particularly of interest in space and in ventilation and air conditioning, where the possibility of making a surface texture at the nanoscale that converts excess heat into the wavelength of energy that just goes off on its own, or even if there's no atmosphere, is very exciting. It's a much more efficient way of cooling than conventional cooling. And we've demonstrated this at the small scale, so we can show some results, but it's really exciting.
You mentioned thermal properties as well, right? Because that would be interesting in space.
That's right. So there's a question on the table. There's a lot of IP in this area. Is yours in the method rather than the utility functionality? And the answer is it's both. And as a tech transfer company, our job is to identify the important parts of IP that are coming out and grab licenses for them all. That's why we're working with so many different institutions, because they have such great fundamentals for us to grab hold of and put into our portfolio. We consider that the fundamental IP for getting this process working in open air on multiple materials came from the University of Rochester, the Institute of Optics. And that's our anchor license with Rochester. But we're also talking to Penn State and the Hyles Institute in the Czech Republic and the University of Quebec in Chicoutimi.
Wonderful. Thank you so much, Dan. Excellent presentation. This was the last presentation. You had everybody captive.